In this video, we are going to be starting our study of graphing parabolas. You're going to spend a lot of time doing this in Math 110, so I am just introducing the idea of graphing parabolas. Parabolas are anything that is x squared. So when you take a quadratic, x squared plus something, and you graph it, you get out a parabola, which is this U shape that you see on the screen. That is called a parabola. They can open upward or downward. How you know if A is positive, they open upward. If A is negative, it's going to be flipped upside down and open downward. Some terminology, we have what's called the vertex. The vertex is the very center of the graph. It's either the lowest or the highest point, depending on which way it's facing. The way you find the vertex is if a quadratic is in standard form, which is this, then the vertex is the point HK. Notice from the formula that it is switching because H is negative in vertex form and positive in the actual vertex. K, however, doesn't change. So H is the opposite, K is the same. You also have these things, the dots that cross the x-axis. Those are the solutions or roots, zeros, x-intercepts. All four of those words mean the same thing. So every time that we've been solving with completing the square, factoring, or quadratic formula, we've actually been finding the x-intercepts on the graph. So here's our first example. We're given the equation y equals -2 x minus 1 squared all plus 5. If you notice, that thing is already in vertex form. So part 1 or step 1 asks to determine whether the graph opens upward or downward. Well, because a, -2, is negative, then I can see that the graph opens downward. That means it's going to be flipped upside down. The second part says determine whether the graph is wider or narrower than y equals 1/2 x minus 1 squared plus 5. So this number out front, 1/2, fractions make graphs skinnier, whole numbers make graphs narrower. So this graph is actually narrower than the one that we're given here. So the next part says to find the vertex. Well, because this thing is already given in vertex form, I am just pulling out HK. So here I can see H and K. Now if you remember, H will switch, so I'll have +1, +5. Because H switches and it was negative, it turns to positive, and K stays the same. So my vertex is the point 1,5. Find the point on the graph of the parabola that has x equals 1. Well, what you're going to do is take x equals -1 and plug it in where there was an x. So then you'll have -1 minus 1 squared. You're just going to do your order of operations, and then you get out y equals -3. So the point is the point -1, -3. Because you take the y value or the x value and then the y value you found. Second example is to kind of take something in standard form, which is what we've been working with up to now, and turn it into vertex form. So the question says, you're given this equation, y equals x squared minus 8x plus 22, and I want to rewrite that equation in vertex form. You're going to do this a lot in Math 110. So the first thing you do is you have to work on completing the square. Because if you remember, completing the square gave me a big parentheses squared, which is similar to vertex form. A big parenthesis squared. So I'm going to just take the 22 and push it over a little bit. Now I'm going to take that part that's inside the parentheses, and that's what I'm actually going to complete the square on. So I take b, divide by 2, square it, so I get -8 divided by 2 is -4, -4 squared is 16. So I'm going to add, normally I add that to both sides, However, because I'm working on the same side as the equal sign, so notice in this step right here, everything is on the right side of the equal sign. So I'm actually going to add 16 and subtract 16 because it's really like I'm adding 0 because plus and minus cancel each other out. So this is a little bit different than when we normally completed the square, and again that's because I'm doing everything on the right side of the equal sign. So I can't add it to both sides, I have to add it all to one side, so I have to add the positive version and then subtract it. Now from there you're going to simplify those numbers off to the right. Simplify this part. 22 plus negative 16 or 22 minus 16 gives you 6. And then on the right hand side I'm going to take that parenthesis and write it as a binomial squared, which is going to give me x minus 4 squared because the number before I squared it was negative 4. So now that equation is in vertex form. So part 2 is going to ask you to, okay, find the vertex. So I need to find HK. Well, luckily I just put it in vertex form. So my vertex is H opposite K regular. So my vertex is the point 46. Third part says, okay, now let's find how many real zeros. So if you think back, this goes all the way back to 10.2. So I'm going to take it back in standard form because I know the discriminant off of standard form is much easier to work with than vertex form. So I do my b squared divided by, or b squared minus 4ac. I plug in, I put that thing in my calculator, and I get out negative 24. Negative 24 says that I have two imaginary solutions because the discriminant is negative. So I'm looking for how many real zeros there are, so I have 0 real zeros. If you get a positive discriminant, that means you have 2 real zeros, and if you get 0 for a discriminant, that means you have 1. Last part is going to then find 2 points on the parabola. I'm just arbitrarily going to pick a value for x, plug it in, and get out a y. So the first one I said was, okay, let's let x equal 5. I just picked 5. You can pick whatever number you want. You can pick 5 too. I'm going to then plug in 5. I plugged it in to the standard form version. So I plugged in 5. I put it in my calculator. I got out y equals 7. So that means my first point is 5, 7. For the next one, I picked, well, let's let x equal 3. So now I'm doing the same thing again. I plugged in 3 to the standard form. I got out 7. And so my 2 points are the points 5, 7 and 3, 7. So then those are the 2 points. I would graph those and connect them up with a nice little curve.